16 2.5 megawatt Clipper Liberty turbines that are here on site. They produce a total of 40 megawatts of energy. And I'll just give you...
For the camera, could you introduce yourself first?
Oh, okay. I'm Brad Drake, Assistant Operations Manager at the Sheffield Wind Farm for First Wind. So that's the site stats as far as just your total sizing. 16 turbines, 2.5 megawatts each for a total of 40 megawatts. A little background on First Wind as a company. They're founded in '02 and they're headquartered in Boston with over 200 employees, give or take. This is a little bit of a dated presentation, about a year old. So the wind projects that they have currently range from 15 is a smaller one to 205 megawatts is larger ones that exist out in like Utah and California. Private, state, and federal lands. As you can see, our core market locations for First Wind are the Northeast and the West, predominantly the Northeast. We have 8 current projects in the Northeast, with 2 more under construction right now and set to be online by the end of 2012. We have 2 large facilities in Utah and 2 in Hawaii as well. And the Hawaii ones with multiple phases, we just completed the second phase of what's called KWP in Maui. I was just working on the Kauailoa project in Oahu that will be slated to be the largest wind project in the state of Hawaii once complete at 30 megawatts. We have an operating fleet of a total generation of 750 megawatts. You can see our sites there that are currently operating. KWP1 additionally has a phase 2 complete at this point. Let me see, Palouse is under construction, that's in Washington, and there's another one called Bull Hill that's in mid-Maine, not northern or southern, just kind of the middle of the state. That's ongoing as well, under construction. We are, like I said, headquartered in Boston, anchored in New England. The first utility scale wind project we have was in New England. It's called Mars Hill. It was 42 megawatts. Currently generating over 500 megawatts of energy in New England with the development of pipeline, including construction-ready projects and prospects in Western Mass. I'm going to zoom up to a map that shows where we have. I thought we had a map here that shows projects that are in development but not yet under construction. I guess I don't have that. We've got offices throughout the U.S. You can see Hawaii in the west and then New England. Not a lot in the middle of the continental U.S. going on right now. So, some of the reasonable answers to energy demand that wind energy provides. Fuel diversity, not subject to global demand. Competitive and stable pricing. The power purchasing agreements and long-term contracts that utility scale wind can provide can offer, these prices that can hedge against rising energy costs. It's stable. It remains a set fixed price for energy, for power. Of course, the environmental benefits are pretty apparent. There's no pollution, no greenhouse emissions. The lowest life cycle impact on wildlife of grid scale energy sources. So of all large grid scale energy sources, you have the lowest impact on wildlife with utility scale wind farms compared to coal, natural gas, etc. Economy, and here you see the major benefits that utility scale wind can provide that, for instance, maybe small scale wind can't. Property taxes. We give almost $520,000 annually to the town of Sheffield. It's a township that this wind farm is located in. they can use that however they want. I think this year they decided to cut taxes by 80%. That's how they decided to use that revenue this year, those tax breaks. We also generate $250,000 annually for the State of Vermont Education Fund. So your two largest points of revenue go directly to the township, where you have these parks located, and also to the state. Of course, you have your jobs and contracting opportunities. Like I said, I was with a general contractor during construction of Sheffield, and we kept tallies throughout the whole time of hiring local, and predominant percentages. At one point in time it was over 70. Throughout the project you have different disciplines on site, different aspects, so that changes from civil work to mechanical work, but we had high percentages of local hires throughout the project. And now currently everyone that works here on site in operations and maintenance lives in Vermont, and I think out of the 6 that are on site, only 2 were not originally from Vermont or locals. And you have the lease payments as well. So landowners that provide the land for these parks get a certain percentage as well. That's usually, it can be broken up differently, but that's usually a percentage of generated energy per turbine. So if there's 5 landowners and one of them has all 10 turbines, and each of them have 1 and one has 10 on his property, he'll of course generate more payments and revenue for himself. That's how that works. Feel free to stop me at any time with any questions as well throughout this.
Thanks.
So Sheffield wind, like I said, 40 megawatts, 16 clipper, 2.5 megawatt turbines. Construction started in 2010, though development was significantly earlier than that. I think development started in 2003. Construction started September 2010. Commercial operation date, that means the date that the park went online generating energy for the grid, was October 19th, 2011. This is a very important stat that is confused, I see often when discussions about utility wind energy, and specifically this site. There's a lot of misinformation. All the power generated from the Sheffield wind farm is sold to 3 local cooperatives: Washington Electric Cooperative, Vermont Electric Cooperative, and Burlington Electric. Those are 3 state electric co-ops located here. The energy is generated for Vermont and predominantly stays in Vermont. Now, granted, there are areas that I'm sure those cooperatives have transmission lines that leave the state. It's a small state, it's a narrow state. Some probably goes New Hampshire, some probably might go south to New York. I'm not sure exactly, but predominantly the power is generated in the state for the state. This site, when operating at its estimated capacity, that is not saying it's operating at its full capacity, it's operating at what we project for the year based on data gathered for that year's wind predictions, will generate enough annually power enough for 15,000 homes. Cost of the project was approximately $90 million. That was actually increased. It was about $100 million when it was all said and done. So as I said, development started in 2003. I don't have a ton of experience in development, but what I do know is you have a systematic way of looking and deciding where you'd like to place a utility scale wind farm. You have data gathering with meteorological towers to find the wind and make sure the wind's there is first. Right in coordination, and actually before that, what First Wind is, I think, very careful to do and is predominant or paramount to development is it something that the community is in favor of? If it's not supported by the local community, I believe I'd be safe in saying that First Wind does not usually like to or does not want to pursue development in that area. So in 2003 to 06, you had your wind measurement, you had your wildlife studies, and you had your local agreements with the communities. Purchasing agreements and applications submitted and issued and appealed. On this site particular, we had some appellants that filed appeals through permitting that wanted the project halted. The state and federal permitting appeals were denied over and over again. I can't remember how many there were by the Supreme Court and the Vermont Environmental Court, so that in 2010 construction began. 2003 to 2010, first one is permitted and built 4 projects. So in the time it took to begin construction of this site is just an example of permitting and appellancy and how you can have that hold you up. We built 4 other projects in Maine. Over 185 megawatts total by the time we were able to start construction. So the challenges, and I think some of the things that held off construction for so long, was it was the first utility scale wind project in Vermont since Searsburg. I don't have a lot of history on Searsburg, but I do know Vermont was the first state to ever have commercial scale wind energy, which I really think that's awesome, and I think that that says something that we were able to have the first utility scale wind project in Vermont in quite some time, since the days when the technology was a lot different with those first wind farms, or I think it was maybe 1 windmill.
I think you'd have a challenge from some people I know in New Hampshire.
Yeah, maybe.
Who just told me that where they were, this is Crotchet Mountain, was the site of the first commercial wind farm in the United States.
Yeah, I'm sure there's some back and forth on that. I've heard predominantly it was it's called Grandpa's Ridge or something like that was here, and it was one of the first.
Cool.
One of the first. But anyway, so we had the appellants with the appeals to the stormwater permit. We displayed that there were no violations. We were in full compliance throughout construction with those permits, and said appeals were dismissed by the courts. You had also a lot of compromise on the behalf of First Wind with the community and with some of the appellants with redesigns, transportation permits, and the lovely weather up here in Vermont as well. And I'll touch upon a little bit of those here in just a sec. Some of the redesigns, and I think why in the end the compromise that we put forth with the local communities and some of the appellants proved successful to go ahead and construct the project was a smaller project footprint. Originally the project was slated for 26 turbines. They were smaller. I think it was 26 2 megawatt or 1 point somewhat megawatt turbines. We reduced that size to 16 total turbines and a higher megawatt of 2.5. Those 10 turbines were in another township and county that voted against the wind farm. So we did not build it in that county, and we stayed where the community support was. We also reduced wetland impacts from over half an acre to less than 0.09 acres. So less than 0.1 acres of Army Corps regulated wetland, which can mean a variety of things, was impacted during construction. This site, something I was responsible for during construction with the general contractor, was environmental compliance. I was the environmental compliance manager. And the stormwater infrastructure and system that you guys will see here shortly is probably the most expensive, extensive, and complex stormwater system at any wind park in the U.S. I mean, I can't say that unequivocally with data to back it up. I bet there's not one out there that is as complex and substantial as this one. The permitting that we had that was required for this site, and in Vermont in general, as you may know, in New Hampshire and in New England, is very, very stringent, unbelievably stringent. We had turbidity readings and turbidity compliance levels that basically were nil to comply with on the local headwaters and streams and things of that nature that we had to make sure not impact during construction. So I'm very proud of that, and I know First One's very proud of that, and the fact that we had no violations and we were in full compliance from a stormwater and environmental stance throughout the project was pretty amazing. We also volunteered 2,700 acres of land protection and bear habitat protection with this project. I don't know the timeline, I don't know if it's infinite, but I do know it's, I don't think anyone can touch that for the next 4 or 5 decades. And please don't quote me on that. I have not been privy to a lot of this information, being pretty new with the company, but I don't think anybody can touch that 2,700 acres allocated for quite some time. We also have what's called back curtailment. We're actually doing that right now. If we see some of the turbines not spinning, that could be why. For the first 2 years of the project, during bat migrating seasons, when we reach specific parameters in the field, air temperature and wind speeds, in different times of the day, it's predominantly at night, but sometimes during the day, the curtailment kicks in automatically. These are smart towers. We can program them to do what we want them to do, and the towers will stop and shut down. So we have 16 out there, half of which during the curtailment shut down during when those parameters kick in. And there's also bat and bird studies that go along with that, looking at mortality rates or fatality rates with the bats and the birds.
That's one of the big issues. What are you finding with those studies?
It's pretty minimal. What I've seen throughout the United States with averages is, bats somewhere between an average, let's say, of around 20 bats a year or 30 bats a year. Birds maybe similar or double that, but I don't really have those numbers.
Per turbine or?
No, total no. For the whole park. Probably less than 1% as many birds or bats that are killed by vehicles driving down the highway in a given year. Probably, half of a percentage or maybe a point percentage of avian mortality as compared to vehicles. I do know it's some odd like tenfold exponentially the amount are killed by wind turbines are killed by windows. Birds flying into windows. I wish I had those numbers, gentlemen. I'm sorry.
No, it's fine. It's just that one of the this one I'll cut this out of the tape. But one of the things I want to do is discuss the things that are the typical roadblocks and hear what the real answers are to them, because a lot of times they're
Yeah. And I don't know that there were a lot of permitted requirements with that back curtailment. We offered that. I think the bird studies that have been ongoing for a while, and that's another source of huge misinformation that you find online and with appellancy, is extremely inflated and not compared to other things like trucks and windows. So strong, consistent support for the farm. Really, we couldn't have built this farm without those utilities holding on with us throughout the 7 years it took for development. Holding on to their agreements and their customers in support of this. The landowners as well. We could not have done it without the landowners holding on throughout the same, and the local residents supporting it the whole time. That's a long process with a lot of appellancy for people to stay strong to their commitment on what they want, which is energy independence in the state of Vermont.
So the landowners lease to
That's
First
correct.
Wind?
That's correct. They lease to First Wind. That's correct.
Is there a minimum length of lease? How's that?
The park has warranties for 20 plus years, so I imagine the leases are right there with that, if not more. I don't know. I know that's what the turbines mechanically have themselves. Here you can see the site. Where we are right now, we're standing down here in this ops building. We'll drive in. You have two basic ridge lines where we had our best wind data. We have 5 turbines here, 3 here, and then the rest to dot out the 16 are associated on out to the rest of the site. You can see the green were the wetlands. So, excuse me, you can see where we built the park, basically threading needles around the wetlands. It would have been much easier to cut a road right up the ridge, right through that wetland in just one linear fashion. The development, the concerns for minimal impact are awesome on this site. I'll explain some more of that in detail here in a second, but when you have a developer like First Wind that really cares about impact, it's amazing the engineering feat that you can have with a park like this, and it's amazing what you're going to see out there, how we have threaded that needle, and how we've diminished impacts that a lot of other developers do not do.
Did you find that the appellants were generally local residents that were upset with the project, or was it more corporate like other utilities?
What I would say is spearheading the appellancy from the beginning, from what I've heard and understood, it was second homeowners from out of state with property on Crystal Lake that does look up to the wind farm. I think that's where a lot of the original appellant movement began, and where a lot of the funding came from. My answer, off the record, unequivocally, is no. It is not from the locals. This has community local support. My girlfriend's father lives here. He can see half the wind farms from where he lives. He's a dairy farmer. He's lived here his whole life. Him and his buddies and all the good old guys that I talk to that have been here farming the land for a long time, they can honestly care less. They could honestly care less about the aesthetic. I don't think there's a lot of local appellancy that is not somehow tied with misinformation as well. Most of the people I talk to that show anti-sentiment turned out to be misinformed. And I'm not just saying that. I enjoy I guess some aspect of education when I talk to these guys. At the same time, it really bugs me that they think these things. Oh, there's diesel engines up in those turbines that can leak. No, there's not. There's no diesel engines on the site. There's no CO2 emissions from these things. Absolutely not. So the misinformation really gets to me, but I do enjoy getting a chance that I absolutely know the answers to these questions or these rumors or these myths and can dispel them. I do enjoy talking to the locals sometimes, and after I do, lots of times I find a little bit different attitude at the end of those conversations. Going back to what I was saying on what First Wind has done development-wise on this project for minimal impact, there's a few main features that are pretty cool. One is narrower roadways. You have to construct a certain width of roadway to provide crane access to erect these towers. It's pretty wide. Given it's pretty wide, 20 to 25 feet, if you think that's wide. What we've done is come back and vegetate, as you can see, a certain percentage of that roadway, decreasing overall impacts and decreasing overall stormwater runoff from the site. We did the same thing with clearing. We have some of the smallest turbine pads, and guys, I've been doing this 3 years. I've seen a lot of wind sites. Some of the smallest, or doing the construction, aspect, not the ops aspect, for a few years. Some of the smallest pad sites I've ever seen. It's pretty amazing that we erected towers with what you'll see is the small crane pads and the small areas we had to deal with. We really tested the crane operators out. What they also do is lots of times you will see clearing for a blade. You'll see basically the whole radius cleared for that blade. What we did was what was called wing tip clearing, where you only clear out what you need just for the tip. You don't clear out the whole swath for the blade. You clear out just enough for that tip to fit within the woods, and then you pick, when you make your rotor pick that has all 3 blades at once, you have to perform that pretty gracefully to get that to come straight up from the ground. This is a typical picture here you can see of a small pad site. Maybe you can kind of tell how small that is. Those are regular sized pickup trucks and forklifts. And you see how much space they take up on that pad site. Not a lot of extra room down there. That's a stormwater basin on the right there. You'll see those as we get out on the site. Those are one of the stormwater controls I was referring to that are extremely expensive, complex, and do a good job at keeping the rivers free of sediment. We had a couple no-impact stream crossings. I don't know if you or students have any experience with construction, but building something over a stream without impacting it whatsoever is pretty hard. There's some pretty cool engineering feats on the site I'll show you that we did out there as well. Where we had 0 impact streams that the Army Corps would like us to not impact. We did so. That's a stormwater basin again. Those are just some of the control measures I'll show you on site that we had throughout construction, maintaining compliance with permitting. We worked through the winter on this site. I guess that's just a little novelty slide there. It was cold, it was hard, but we built a lot of the site in the wintertime. There's a typical foundation for a turbine. These are what's called spread footer foundations. They're approximately 8 to 10, maybe 12 at the most feet deep. Not the myth and rumor that I hear a lot of times out there in the public that they're 20 or 30 foot deep in the ground. These are spread footers that are, I can't remember the radius, please don't quote me, maybe 30 feet in radius and maybe 8 to 10 feet deep. Filled with rebar, that's what holds the turbine up from the base. Collector line, that was the third aspect of what we did here to minimize impact. Most farms have overhead electrical tying in from the turbines to the substation and subsequently the grid. We have underground collector throughout the whole site. That means you don't clear as many trees, you don't have as much construction. You have your collector line buried in your roadway or right adjacent to the roadway.
Is that particular to Vermont, or is that...
No, we do it in other sites. We do it in a lot of other sites. It's just a more expensive application. It's a harder application, but it minimizes impact greatly. Got some pictures there of the collector line coiled up before it gets unrolled into those trenches. A couple example of pad mount transformers that convert current from DC to AC before transmission down to the substation. That's some examples of turbine delivery. We challenged those guys as well. They had to bring their A game on this site. We gave them 16-foot roads. I've never heard so many expletives regarding the size of roads for their transportation and delivery, but they got it done. And in August, that's the last site, August 2011. Those are the last oversized deliveries made to the site. That's some photos of the turbine erection during the summer. And the finished product. 16 turbines, so spinning efficiently and generating clean energy for the state of Vermont. Last winter we had a very great production value for the site. We were producing over 40 megawatts, which they are capable of exceeding their threaded or standard amount, which we did in spades in the wintertime. We had great generation. That's some technical data there. I don't think we want to go into that too much. This is the ops building we're sitting in. It's located off New Dock Pond Road. Basically, we've got some pretty cool computing hardware and data acquisition stuff here that monitors the turbines. They're monitored in real time. A lot of people don't know this, that they're smart turbines. They're monitored 24/7, 365. They send me little updates to my iPhone anytime any little thing happens up there that we don't like, any hiccups in service. I can get wind speeds, I can get power generation, any of that in real time. It's tied into Data Acquisition and Control Center, which is called First Wind DAC. We have one located in Boston and one in California. These are tied into the larger energy co-ops and providers throughout the U.S. So everything is not only monitored federally, on a federal level, state level, also by ourselves at all times to make sure everything's operating safe. These are smart turbines. They can turn themselves into the wind. They pitch their blades the right way into the wind. They do everything they need to do to get the best possible generation of power they can. That being said, if there's a hurricane that comes in, a nor'easter, and it's producing extreme wind speeds, they can brake themselves. They can pitch their blades out of the wind. They can slow themselves down and protect themselves from damage, which is pretty cool. These towers are 262 feet to the hub. You go ahead and throw on that blade to the tip, 414 feet tall from ground elevation base to tip of blade. Roughly, we say they're about 300 feet. The blade diameter is 300 feet, 14 feet. Each blade's about 160 feet long. So again, average height is 260 feet to 414 feet tip of blade. Everybody always wants to know that. Each tower consists of the following major components. This is some technical jargon, but it is, I think, good for students to know these different components. Basically, you have the nacelle, which holds the gearbox and generator. You have your hub, which connects to your gearbox and generator. Your blades, of course, your rotor blades. The whole assembly here is called your rotor. Then you have your tower, which is basically a 4 or 5 section tower. These are 4-section towers. On this site, you have your collector line that runs down from your generators. You have your pad mount transformers that will convert DC to AC and then go into your collector system underground down to the substation. Substation hits a main power transformer, juices it up from 34.5 kilovolts to 115 kilovolts before exiting on Velco's Vermont Electric Cooperative's main transmission lines for distribution. Some pictures of the inside of the tower, and that's it on the presentation in the office. Any questions?
Yeah, I do, but
What's the payback period for the entire farm?
I think it's proprietary, I'm not sure. I think averages are 5 years, I'd say.
Oh, wow.
Yeah, 5 to 10 years, I think, is what I've heard through the grapevine.
and what's the life expectancy of a wind turbine?
They're warranted for over 20 years, just over 20 years if memory serves me. And the other thing about that is as technology increases with the components, efficiency will increase too throughout time. These are all, they're like Legos, they're all completely upgradable, to an extent. You probably aren't going to go put in a new foundation, but you can put in different filtering devices, smartware, braking systems, gearboxes, etc. that can increase life expectancy and efficiency.
What's your background?
I went to school, I graduated in 2000 with a BS in environmental science.
From where?
University of Arkansas.
Oh.
Northwest Arkansas in Fayetteville is where I grew up. I went on to do remediation for a few years. A lot of cleanup, different environmental remediation throughout the years, from gas stations to solvent factories. Worked in Chicago for a number of years along the sanitary shipping canal on old Superfund sites and stuff like that for years before I got into renewables.
Tell me about the potential for job opportunities for students in wind.
Well, I mean, from my limited, knowledge of that, from a layman's terms, from just, my interpretation, as the government approves the PTC for next year, if they do.
Just 1 second, I just want to let you know that I'm leaving.
Okay.
And don't worry about FedEx, I'm going to stop at St. Johnsbury anyway. So.
Are you sure?
Yeah, no problem.
Okay.
So, one less thing for you to do.
I did not get a text back giving me an answer.
Okay. Don't sweat. I'll just
Sorry
drop it.
about
I'll just
that.
drop it on the way. No, I appreciate it.
Okay, well, thank you very much.
Okay, well, thank you.
All right, have a good day.
All right.
I'd say this, as more wind development and the tax credits kick back in, which I feel confident they will, for 2014. I think 2013 is a wash. And you have more renewable energy development, I'd say you're going to start seeing more programs, academic programs, geared specifically towards the mechanical engineering or the civil engineering, civil construction, or the environmental permitting that goes hand in hand with wind and solar, utility scale wind and solar construction and projects. If I knew what I knew now and wanted to get into renewables when I started in the game, there's two ways you can do that, from the construction side or from the operations side. And I think everybody should start in the construction side if they really want to cut their teeth and know what they're dealing with out there. Mechanical engineering and civil engineering degrees would be very helpful in moving fast in this industry.
Are there any fundamental differences other than scale between small scale, like residential community wind, and utility scale wind?
Absolutely. The greatest fundamental difference is the amount of power that can be generated. It's a match compared to a blowtorch. Not in any way degrading the need
Understood.
or use or opportunity in the pursuance of small scale wind. But the need, I think, and demand for utility scale wind is real, and it's there. And I think you could give everybody a solar panel and a wind farm in their backyard, and that'd be a wonderful step forward, but I don't think it would have the impact with regards to power generation as one utility scale wind farm in that township, county, community. It's just no comparison. 40 megawatts of power is a lot. It's a lot. So that's the main difference. And I think the technology as well. I mean, you could talk about aesthetics all day long. I mean,
But what about the technology? Is it significantly different?
Well, from what I've heard, is you have to get off the ground. You have to get up there and get the wind. Zoning, I mean, what kind of residential area has zoning for a 200-foot tower in your backyard? I mean, so those are the type of things we're going to have to be progressive about as a country, I guess, in the next few years as technology develops. And there are ways to, say, different rotor types that can harness more energy. There's a new technology that we're looking into, and again, don't quote me on the specific, but I think it's called funnel technology. It's a way to harness with a bigger wind with a bigger end, reward. It really grabs what's there more efficiently than your typical turbine, typical rotor. So those things can develop, those things can increase and help us on a small scale level as well as a large scale level. But then the aesthetics and the zoning and that kind of thing would be, I think, the biggest hurdle over anything. That's our biggest hurdle.
What's the minimum average wind speed you need for an installation this side?
I couldn't tell you that number. I wouldn't even want to guess.
I know for residential it's usually around 12.
Meters?
12 miles per hour.
Okay. It's probably 20 then, because I know we average, and we don't measure miles per hour. I think we measure meters.
Meters per second.
And meters per second, and I think 20 is, I mean, that's typical.
Mm-hmm.
That's like a decent day. 30 and 40 is what we want, and we get it here.
Is there a maximum before? Well, you said they furl it. So
Yeah, and I don't know what that is. Again, I'm sorry, just too new to ops. But yeah,
that's okay.
There's a wind speed where they pitch out of the wind, and there's a yaw break, where the yaw is what turns that nacelle, and it will yaw. There's a yaw break it'll turn out of the wind, and it'll also break that rotor from spinning, feathers it slowly, doesn't just slam on the brakes.
Excellent. Thank you very much.
Heck yeah.
Have you had any issues? I know we passed a wind tax exemption, property tax exemption in our town, and as soon as we did that, we got all kinds of letters from audiologists and all kinds of people complaining about the noise that, yes.
So that's the latest. It's very important to me, and it's something I'm studying on my own dime right now. The noise thing that's going on, the misinformation with the noise. The greatest thing that you guys get to do is we can walk out here and I can say, what do you guys think? You tell me what you think. We've had independent noise studies done that met all requirements, state requirements that we had with permitting. That doesn't mean you still don't have people complain. There's a lot of misinformation out there right now. I'm seeing from a guy out of Europe. He's big right now, leading this movement that talk about ultrasonic or subsonic sound created from these guys. In my opinion, it's a bunch of BS. And to me, it's white noise. Definitely not going to deny there's noise that comes off of those. Low cloud cover, spinning it, 90 those tips can get up to 90 miles an hour with good generation. They cut through that cloud cover. You hear it. To me, it's a whoosh. It's a light white noise sound. Right under it, you can talk without raising your voice, and it's not overpowering. Standing right under the thing, full bore, just flying. You can stand there and talk like this.
Yep.
So that's my opinion. And also, when you just hear it in the background, like here, hundreds of meters or hundreds of feet away from a turbine that's ginning real good, like would be the closest house you'd ever have. To me, it sounds like a bit of a waterfall or a river, some type of white noise. It doesn't sound mechanical to me in any way. It doesn't have a mechanical nature to it. It's wind,
Excellent.
Yeah.
Interesting. Do you find that utilities are requesting more proposals for wind, or what pushes is it the business side say, hey,
Pushes it is that tax credit that we had through Obama that got that passed in his first year of legislation, where we had the power something. It's the PTC. It's the tax credit that the power co-ops get, or the power companies get, from investing in building renewable energy. That didn't pass for 2013. Right now, development, manufacturing, and construction of wind farms for 2013 is at a standstill. There's nothing on the books because of that. So that gets kicked back in for 2014. You'll see development ramp back up, and you'll see wind farms going back in. So the subsidies, are
is the thought that we need, based on these new installations like this one, we need to see a certain amount of data to say this makes sense, it doesn't make sense to you?
No, I think it's more just building costs and the funding.
You mean the reason for holding up the tax credit?
Yeah. I don't know why.
I couldn't speak
I can
to,
imagine why it might not get passed, but I understand.
That's what I would say.
But on the other hand, maybe it does allow
business.
there to be a certain baseline of data to say that this sort of thing works at different levels and
and I think
generate
honestly,
more.
I don't think it has anything to do with it. I think there's 100 sites out there that could display solid, clean wind generation and be great site for a wind farm. I don't think that has anything to do with Congress and why those credits do or do not get passed. Honestly, it's not a matter of is the technology proven, is the impact minimal, and is that proven? In my opinion, you can go back and forth, and the only place you ever get hung up is aesthetics. If you don't like to look at them, you're never going to like to look at them.
Right. I was thinking more in terms of dollars and cents on the business side. With the incentives, obviously, the payback period is going to be less.
Right.
And, but is it significantly more without the tax credits, and why aren't the utilities clamoring?
I'm sorry, I see what you're saying. I think because the difference there is pretty substantial when they get the tax credits versus.
It's that big.
I think so.
I think it's 30%.
Oh, okay.
I think it's a big difference there. Yeah.
That would be a big difference.
Yeah.
Cool.
Yeah.
Thank you very much.
I hope that gets kicked in.
I'm sure you do.
Talking to a recent senator, he thinks it will be. So cross our fingers.
Yeah.
You set?
Yep.
Great.
30%, 20, 30%. It's really pretty decent.
Doesn't seem like there's that much wind, so.
No, there's not. 262 feet up. There's some where it would be current, but yeah, it's definitely not one.
How much, well then, now what you have to do is subtract any electronics that are in here. I mean, this is probably making noise.
Yeah, so that's the timeout transformer.
Transformers make noise all the time.
This is true. To me, it's a little bit less noise than your regular residential air conditioner makes.
Yeah?
Right?
Yeah, this is what I'm
We're standing
I'm not
this-
hearing that.
If we're standing
I'd
this,
have to give this a...
if we're standing this close to a residential air conditioner, it's louder than
This application is.
In my opinion.
I have a real-time analyzer on here.
this. And you know, like I said, that turbine's probably spinning, I'd say anywhere from 20 to 30% capacity. So it's not spinning very fast, but I don't really hear any blade noise. Heard these fans here. Heard the fans in there really.
Maybe the fans are blowing because it's actually
This is running at about 70 to 80%, and you can hear quite clearly the sound of the turbine, most of which is the fans and electronics. This gives you some idea of the scale. Here are the guys. Here's the base of the wind turbine. You can't really see it, but can you hear it? Listen carefully. We're not more than 100 feet away from it. Pretty quiet.